Alright, so we're going to finish up our geometry unit. We're going to talk about some basic geometry transformations today. You talk about this with students in high school with a very specific coordinate plane definition. In other words, here's a point x, y, and how am I going to change it in some different ways. But we want to kind of get away from that, and we want to cover it just at the elementary level or junior high level. So first, let's talk about what transformations are. Kind of like the movie Transformers. The word transformation just means changes. Okay, and there are four main types of changes that you're going to need to be aware of. The first one is a translation. Okay, the quick way to describe a translation is a slide. Okay, so it's just when you slide the figure maybe up or down or right or left. Okay, the technical definition is when every point on the figure moves the same distance and in the same direction. So an example might be if you started off with, let's say, a triangle, okay, and let's say that you slid it right and down. Okay, so notice the figure did not get flipped over. Okay, it stayed the same shape, it stayed the same orientation or the same direction. Okay, all we did was slide it. The second type of change that we can have is a reflection. So a quick way to describe a reflection is just a flip. Usually it's a flip over a line, okay, of some sort. So it's a flip, but it is more specifically when every point is reflected over a line. Okay, so this one's a little more specific. So usually you'll show the line something like this. So let's say that this is our figure as it originally is stated. This is originally what we have. Then if you're going to reflect this shape over this line, so if we're going to reflect, that means we're going to go this way. Okay, and it's going to be equally distant from the line. I'm kind of winging this, so the shape doesn't change. Okay, it just reflects over that line or flips over that line. Also keep in mind that, for instance, if it would have been, let's try a different shape just to show something. If it would have been a triangle, when you flip it, it will be upside down. So it's not just sliding it over the line, it is flipping it over the line. Okay, that's the distinction. So we'll say this or that shape. And the third change we can have is a rotation. So a quick way to describe a rotation is a turn. You will usually specify this with degrees. Okay, so this is when every point is rotated about a point. In other words, that's where the center is kind of marked, but a certain number of degrees. All right, so let's say that we had maybe a trapezoid shape originally. And we wanted to rotate that. So let's say that we want to rotate 90 degrees. You're also going to see probably either a description that it is clockwise or counterclockwise. In other words, clockwise going the direction that the hands move on a clock, counterclockwise going the other way. Okay, so it means we're going to be turning this way. Okay, we're going to be starting from the left and turning to the right. Okay, so if we do a 90-degree rotation, then the long slide moves this way, and it would be something like this. Okay, now granted, these figures are supposed to look perfectly the same. I know that my drawing skills aren't perfect. Okay. And the fourth way, we're not going to talk about this a whole lot, but I do want you to recognize what it is. A dilation is a reduction or an enlargement. I'm going to say by a scale factor. Okay, so a scale factor that's larger than 1 is going to be an enlargement. Okay, a scale factor that is less than 1 indicates a reduction. So let's go ahead and write that down. So scale factor is greater than 1. So in other words, if the scale factor was, for instance, 3, you would be making the shape 3 times bigger in every way. All the measurements would be triple. But if the scale factor was, say, a half, you would be making all the measurements reduced to a half of their current length. So scale factors less than 1, any fraction less than 1 indicate a reduction. Okay, so in your practice activities this week, or in your printout worksheets, there is some graph paper. One of the pages is 1 inch, one of them is 1/2 inch. Okay, and so I printed it off on front and back here. It doesn't really matter which side you use. Okay, so what you're going to do with these, just because for the activity we're about to do, we kind of need to section it off. So maybe with a marker or something, let's go ahead and partition this off into quarters. Okay, so we're going to call this the X and this the Y. Okay, so I want you to take out your pattern blocks and see if you can find the following shapes. Now I realize some of your sets didn't include the brown and the purple, okay, so if that's the case you can substitute different colors, okay. The point of this assignment is that you practice kind of shifting these things, okay. But if you have all the pieces, okay, so I'm going to push those off to the side, I want you to take out this activity and we're going to change it up a little bit. Okay, so you might have to pause the video so that you can fix all of this stuff, but I'm going to use red, blue, brown, and purple, and then also the orange square. Okay, and so what I want you to practice, okay, I want you to practice doing these things. So for instance, okay, let's take the first one. So again, let me put that up there. So change all of these to red, blue, brown, purple, orange. Okay. This assignment was originally to be used with color tiles. The reason I don't want to use color tiles is because they're all squares, and it's not always clear when you are flipping or rotating a square because it's the same on all sides, right? So I wanted to use some different shapes to kind of get the feel of it. All right, so let's look at the first one. I want you to draw your red trapezoid somewhere. I don't care where, okay? And then you're going to reflect it over the x-axis. So you're going to trace this. Okay, now you could put it there. You could put it there. You can put it anywhere you'd like. So you're going to draw the original, okay, and then you're going to talk about what would change if you did a reflection over the x-axis like that worksheet says, okay. So notice that if I left it here, for instance, okay, if I reflected it, it's going to flip upside down and be here, okay. Notice if I would have put it here, okay, I put it upside down and I reflected over the x-axis. Notice that it's 2 units above the axis, and so when you come, you're going to flip it upside down and also flip it 2 units below. Okay, so I want you to see if you can do kind of all of the different reflections. So reflections, translations, rotations, and then there is a dilation. So I want to talk about the dilation. So if you place the dilation here, for instance, okay, that's the very last one on the page. If I tell you to dilate it with a scale factor of 1/2, that means this square needs to get half as big. Okay, so literally it's just going to be right on top of this and half the size. Okay, so you kind of section off half of that shape. So the biggest thing that I want you to do is pause the video and kind of practice seeing if you can trace and draw and do the slides, do the flips, and also do the rotations. Okay, a little bit of the dilations, but I'm not as concerned with that. All right, so pause the video and make sure you do that. All right, so after you've looked at that handout that I gave you, I want to talk about one more thing. I want to talk about a concept called symmetry. Okay, so the definition of symmetry is the quality of being exactly the same on one side as you are the other. Okay, so a lot of times when we're doing things like reflections or translations or rotations, we might have some symmetry involved. Okay, so I want to look at some examples of maybe some letters that have certain kinds of symmetry. So let's look at the capital A. Okay, is there a way I could split the capital A in half, okay, so that it would be the same on one side as it is on the other? Notice I could do it just like this, right? Okay, so this would be a shape that has what we call vertical symmetry, because if we can draw a vertical line that will cut the figure in half. Okay, notice it does not have horizontal symmetry, right? I can't cut the figure sideways. So let's look at another letter. So let's look at the letter X, capital X. Okay, so notice this also has, if drawn correctly, right, it also has vertical symmetry. But notice there's another way I could split that figure up, right? So I'm going to use kind of a different color pen. Notice I also can cut it this way, right, with horizontal symmetry. Notice some letters of the alphabet don't have any symmetry at all, right? So if I gave you the letter P, for instance, capital P, okay, notice this has no symmetry whatsoever, right? There's no line you could draw ever that would cut the figure in half. All right, so the concept of symmetry and transformations really kind of goes hand in hand, okay? So I want you to maybe take out and look at the homework for this section, because I'm going to describe kind of what I want a little bit more, okay? Notice the first half is just multiple choice, okay? I know it's blue in color. When you print it off, it probably won't be, but that's all right. So on the first page, this is more questions that I would ask elementary school students. Okay, so notice number 1 says find a reflection of this. Okay, notice it does matter where the dot is. So you need to choose A, B, or C that looks like the figure has been flipped. Okay, and then so on and so forth for the whole first page. Okay, but the second page, I want to be clear about what I'm looking for. Okay, so if you're watching the video, I'll kind of know if you watch the video so that you know what instructions I have for this homework. Notice the instructions say to write a translation, reflection, or rotation. Okay, but I'm going to add some extra instructions. I want you to be specific. Okay, in other words, I don't just want you to tell me it's a translation or a slide. I want you to tell me how it changed. Okay, so let's take the first one for instance. Okay, if you look real close at your assignment, this is marked M and this is marked M with a little apostrophe. Okay, that means that this is the original figure. The one with the regular letters without any extra markings is the original. So the easiest thing to do is to focus on a common point they have. So I'm going to take the pinpoint of that little diamond shape sort of figure. Okay, and notice here's my original, right? And I counted up to and over 1, 2, 3, 4, 5. So what I would want on this is that this has been translated up to and right 2 units, or sorry, right 5 units. Okay, on this one, if you think it's a reflection, I want you to tell me over what. Okay, so is it a reflection over the x-axis? Is it a reflection over the y-axis? Okay. If it's a rotation, I want you to be specific about what degree it is. Okay. So I don't just want you to say translation, I want you to say how it translated. I don't just want you to say reflection, I want you to say what it reflected over. Okay. And I don't just want you to say it rotated, I want you to tell me what degrees you think it rotated. Also, keep in mind you probably need to say whether it's clockwise or counterclockwise. Okay. So that's what I'm looking for on this assignment. I don't expect it to take you very long, okay, especially the front side. The front side's a really, really quick assignment, or the first page, rather, if you're printing it off online and you're not doing front and back. But the second page, I want you to think about a little bit more, okay? So this side right here, I want you to think about, okay? So as usual, if you have any questions, just make sure that you contact me. So just kind of a head note, this topic isn't currently on your review. Okay, and so you will need to make sure that you review the topics of transformations in addition to what your review is for the following week. Okay, so we're testing, remember, the week after this one. Okay.